Alright, so we're going to look at quadratic formula day 2. We're going to learn about this thing called the discriminant, and we're also going to focus on simplifying any of our non-perfect square roots as we get to the very end of each of the problems. So the discriminant is the stuff that is underneath the square root symbol within our quadratic formula. So we have the x is equal to negative b plus or minus the square root. The b squared minus 4ac, what it does is it gives us the number of roots and the nature of those roots of every single equation. So it should probably take out gives us the number of roots. There's always two roots with a quadratic. What it does, it tells us what type of roots they are. So the best part about the discriminant is it is not in any way extra work to check it before you go, because you are going to use it within the formula. But what it can do is it can find excuse me. It can tell you the types of roots. So say it's a non-perfect or it's a non-real roots. If they're not real, the discriminant, just doing this part of it instead of the whole thing, can tell you before you get started. So the discriminant, if we take this expression and our answer ends up being greater than 0, we have two real roots. If this ends up being 0, we have one root, or we should call it the double root. And if it happens to be less than 0 or negative, there are no real roots. So what we should always do when we're using our quadratic formula is check the discriminant before we even get started. So we have b squared, so that's negative 3 squared minus 4 times 2 times negative 5. That gives us 9. Negative 4 and 2 is negative 8. Negative 8, negative 5 is positive 40. That's 49. We know that this thing is going to have two real roots. And now we can move on to the next part of the equation to find out what the two real roots are. So we have our quadratic formula. Always write it down. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the best part. You've already done the work for what was underneath the square root. So on this next stage, and I'm going to put negative and negative 3, so we have a positive 3, plus or minus the square root. We already know that it's 49 underneath the square root. We have 2 times 2 gives us 4. Saves us some of the work because we don't have to actually plug it in. We've already done it. So we now have x is equal to 3 plus or minus the square root of 49 is 7 all over 4. So our answer splits. We have 3 plus 7 over 4, and we have 3 minus 7 over 4. So our two answers, x is equal to 10 fourths, that's this one, or negative 4 over 4. Simplify both, we get 5 halves, or negative 1. We're going to do it again. Check the discriminant as we go. This one's very similar, so we have 3 squared minus 4 times 2 times 5. That gives us 9 minus of negative 4 and 2 is negative 8. Negative 8 times 5 is negative 40. That gives us negative 31. Because this answer is negative, less than 0, we don't have to go any further with this problem. We know that there are no real roots for us to find. Didn't even have to use the quadratic formula in order to do it. And yes, this work is acceptable on the homework if there is a no real roots expression. However, this work has to be shown. A lot of you guys have not been showing your whole work and you are not getting credit until I see that work. Say we've got this one. I'm going to check our discriminant first. B squared minus 4ac. So b squared is negative 6 squared minus 4 times negative 3 times 5. Well, that's 36. That's positive 12. Positive 12 times 5 is positive 60. That gives us 96. Because it is greater than 0, we have two real roots. Let's go find them. So you have x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So negative b, so be negative negative 6, negative negative 6, so positive 6, plus or minus the square root of 96, all over 2 times negative 3, so that gives us negative 6 on the bottom. Oh, don't want to erase all of it. That was weird. Okay, whatever. I'm just gonna negative 6 right there. Okay, I don't know why I kept deleting it all weirdly like that. So we would want to leave it like this because right now out in front is a 1. These three numbers don't share anything in common, but we have to simplify our square roots. From here on out, you have a square root, you've got to simplify it. So we still have the 6, plus or minus, we still have the negative 6 on the bottom. We need to think of perfect squares. Perfect squares like 1, 4, 9, 16, 25, 36, 49, 64, 64 won't work, any of those larger, that go into 96. I want to check 16 and 4, maybe 36. I don't think 36 is going to work, but, you know, worth a shot. 96 divided by 36. Yeah, didn't think so. How about 96 divided by 16? Ooh, there it is. So 16. We always want to try to find the largest perfect square that works. So 16 is our magic number here. So we have 16 times 6 underneath the radical. I can square root the 16. That's 4. I cannot square root the 6, so it stays underneath. We still have the negative 6 underneath. Now these three numbers have something in common. They all have a 2 in common, so we're going to simplify them all. And that leaves us x equals 3 plus or minus 2 square root of 6 all over negative 3. Yes, these two have something in common, but all three of them have to have something in common in order to simplify. So our final answer remains this. Let's try one similar to that one. Yeah. So we have x squared plus 5x plus 2. First thing we should check is our discriminant. B squared minus 4ac. So that gives us 5 squared minus 4 times 1 times 2. So b squared gives us 25 minus 8. That gives us 17. It's positive, so there's two real roots. So we can move on to our next stage, negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative 5 plus or minus the square root of 17 all over 2. Square root of 17, there's no way we can simplify that. It's prime. They don't share anything in common. And we're done right there. So we probably want practice in simplifying those square roots rather than within the overall quadratic formula. So I'm just going to give you a basic one. Let's say we had x equals 12 plus or minus the square root of 120 all over 8. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So none of these work. 49 doesn't work. 36. I believe 36 doesn't go in 120, but again, we'll check. 120 divided by 36. Yep, didn't think so. So maybe 120 divided by 16? Nope. 120 divided by 4. Oops. Yep, there it is. So the biggest number that goes into this one is 4. So we get x is equal to 12 plus or minus the square root of 4 times 30 all over 8. We can square root the 4, brings a 2 to the outside. So now we have x equals 12 plus or minus 2 square root 30 all over 8. We have to make sure that we still can't do anything more with 30. 4 doesn't work, 9 doesn't work, 16 doesn't work, 25 doesn't work. So none of them work after that. We are simplified up. 2 goes into all three of the numbers outside the radical. So the final answer would be 6 plus or minus the square root 30 all over 4.